the recording on for a few minutes so you can see this problem, these two problems. I'm not going to review them, but we're going to do more of the same type of problem going forward. We're going to be doing a lot of the factoring. Factoring is pretty much the next couple of lessons we're going to be factoring. Again, as I was saying, I would I want you to be taking this test on. I will, as soon as I post it, I will send you an email so that you see it. But I hope that some people have answered this, so I know they've gotten my emails. Please let me know if you did not get a, Devana, can you send me an email saying that? Because I'm going to forget. Okay?
Okay, Professor, no problem. Thank you.
Okay, why? Melissa's just having a hard time getting in, and I don't know why. Maybe I should just go back to math 136. It was so simple. I'm sorry. Okay, so as I said, if you if you have anything that you want me to reset, just send me an email. People have, and I think I've done that. Again, as I said, I had sent out an email to each one individually. It was, everybody got their own individual email. I didn't send a group email on this, telling you where you're standing at this point. If I gave you any kind of warning there, I think that you should be getting in touch with me and letting me know where you're standing, what you're proceeding, how you're going forward from here, because we're about a third of the way through the term, and you still have plenty of time to make up work and get a decent mark. But if you're going to let go at this point, you're not going to make it. I'm just going to call Melissa and tell her. Everybody else got on okay, right? Hi, Melissa. Nobody, I have the whole classes on. Nobody seems to be having any problem. I don't know, maybe go out of it and go back on. Because no, ALG, ALG. 5, 4, 6, 7. I don't know. Okay, okay. As I said, maybe just go out of the Zoom. Remember, you have to still put in the 806-435-5099. I don't know, because the only thing, this was the same, we used it on Friday, I didn't change it from Friday. Okay. Okay, bye-bye. Okay, so let's continue now from here. Can everybody okay? Can I erase it now? Anybody not want me to erase it?
Yeah,
Okay,
you could erase it, Professor.
Yeah, we're okay.
okay. So let's do just one more of these. Factoring out of a common monomial factor. Let's say I gave you this example. 20 a squared b squared c squared minus 30 a b squared c plus 25 a squared b c squared. Let's say I had, okay, Messiah, and let's say I have this expression and I want to factor it. And we're going to see there's several different ways of factoring. But whenever we do, we always start out with trying to find what we call a common factor. And we do that by, as we did before, we look at the coefficients 20, 30, and 25 and find the largest number that goes into all of those numbers. And I think everybody will agree that the number is 5. Then we start looking at the letters. And we take each letter individually. Let's deal with the A's first. There's an A squared, an A, and an A squared. What we pick is, as long as there's the same letter in all the terms, then we pick the one that has the lowest exponent. And the lowest exponent is just the plain A because that has an exponent of 1. And we put that down. Then we go to the next letter, which is B. And there's a B squared, a B squared, and a B. Now, if it turns out that one of them doesn't have any B's, then their B is not a common factor. But in this case, there are B's in each term. And again, the lowest exponent is the plain B. And we do the same thing with the C's. I have a C squared, a C, and a C squared. Again, the one with the lowest exponent is the C. That gives me the common factor, the common monomial factor. What we have to do is, remember when we said factoring, we're really dividing it in 2 parts. If we're factoring 15, we're dividing it into 5, and the other factor has to be 3. And I know the other factor is 3 because when I divide 15 by 5, it gives me 3. So in order to find the other part of the factor, the part that goes inside the parentheses, is I take this common factor and divide each term into it. So I divide the 5 into the 20, and that gives me 4. I divide the A into the A squared. Now, when we're dividing variables, what we do is we subtract their exponents. So this is an exponent of 2. There's no exponent here, so it means the exponent is 1. 2 minus 1 is 1. My A exponent is 1, so it's just a plain A. I do the same thing with the B's. B squared divided by B gives me B. Again, 2 minus 1 is 1. And C squared divided by C, same thing. It gives me just plain C. So my first term becomes 4ABC. Now I go to the next term. 5 into negative 30 is negative 6. A into A squared. Now, if I subtracted their exponents, this would be an exponent of 1, and this would be an exponent of 1. 1 minus 1 is 0. Doesn't mean I put down a 0. It means there's no A's left. The B squared divided by the B, that's 2 minus 1, gives me B to the 1, or just plain B. And the C divided by the C, again, as before, with the A's, it cancels out. So my next term is just negative 6B. And finally, I divide to the last term. 5 into 25 is positive 5. The A into the A squared, again, as we had before, gives me A. The B into the B cancels out. No B's left. The C into the C squared gives me C. So my final answer becomes 5ABC times 4ABC minus 6B plus 5AC. We can't combine any of these because they're not like terms. This would be my answer in simplest form. Is there any question about this? Okay. Now, going on from here, just as a reminder, as we had in the question before, if when you divide, every single thing cancels out. The 5 would cancel out, the A would cancel out, the B would cancel out, the C, everything cancels out. There would be nothing left over there. Don't leave it empty. It's a +1. Okay. Now, you can have not only a common monomial factor, you can even have a common binomial factor. For example, I could have something like this. I have this question, 5x times a minus 2b minus 3y times a minus 2b. Here we have actually something that looks pretty complicated, this algebraic expression. But what I noticed is that this parentheses, a minus 2b, is attached both to the 5x and to the 3y. This a minus 2b is a factor. Remember, factor means a multiplier. We're multiplying 5x times the a minus 2b, and we're also multiplying the negative 3y times the a minus 2b. So just like we did with a common monomial factor, we can take this common binomial factor, which is the a minus 2b, and put it in front, and in my second parentheses, put both multipliers of that a minus 2b. The first thing that we multiply the a minus 2b is the 5x. And the second thing we multiply the a minus 2b is the negative 3y. And we get an expression that says a minus 2b, which is my common factor, times 5x minus 3y. Both of these, and if you would have used the distributive property to remove your parentheses, or you used FOIL, in this case, both cases would give you exactly the same result. This is what's called factoring out a common binomial factor. And it just is basically doing the opposite of the distributive property. That's what factoring a common factor is. It's undoing the whole distributive property. I'm going to do another one like this one. Can I erase this? Anybody want me to leave it on still? Okay. So I'm going, you know what? I'm going to leave this one on. I'll erase the top one. Yes, this is your final answer. Let's say I gave you something like this. I'm going to give you a couple of minutes to try it. 3a times x minus y minus 7b times x minus y. I'm going to give you a couple of minutes while I take attendance for you to do that example. Azia? Hi. Nashia? Nashia Allen?
Here.
Here. Now, I have you absent. Have you been absent several times?
A couple of times I emailed you. I was sick.
Okay. Okay, so I'm glad you're back. Annabelkis? Annabelkis?
Yes.
Hi. I'm
Hi,
glad.
how are you?
Emma,
I'm here.
were you here on Friday or did I?
I couldn't get connected on Friday. I had to watch it on the recording.
Okay, great. I'm gonna mark you here then.
Thank you so much.
Messiah,
I'm here.
good, thank you. April's always,
Present.
you're always here. I know. Khadija.
Yes, Professor. I'm here.
Were you here Friday?
I came late on Friday.
Okay,
I had wrote in the chat.
okay, I just changed that. Umar,
Uh-huh.
good, hi, good morning. Yakima,
Morning.
Yakima Ellison. I know I saw her before. Let me check if she's on. Okay. Cheryl, I know you're here. Stacia, I know you're here. Natalie.
I'm here.
Good. Yeah, you're also, I know you're always here. Erica.
Good morning, Professor. I'm here.
Good. Jonathan.
I'm here.
Yeah, I miss hearing your voice.
Oh, thank you.
Luke Minot. Anybody know if is Luke on? Let me see. No, I guess he's not here. Layla, I see you're here.
Yes, I'm here.
Ashley, you're here.
Yeah, I'm here.
Katira, you're here, I know. Jennifer, you're here.
Right here.
Rachel, I saw you come on early, so I know you're here.
I'm here. I couldn't get in Friday because of the password change, but
Okay, I'm gonna change that to you're here because you're usually here. Gloria, I'm having okay, Gloria, I don't. I don't see Gloria. Okay. Corey, I see you here. Denisha, I know you're here, and Devon, I know you're here. Okay, great. So we're okay with that. Okay, and I think I can erase this now. And let me see, I just want to look at the chats. Yeah, I see a bunch of people have the right answer. Okay, so we can just do it. It's clear that the x minus y is a common monomial factor because it's multiplied both by the 3a and by the x minus y. So in our second parentheses, all we have to do is put the two things that are outside, the 3a minus the 7b. So that's how we factor out a common monomial factor, a binomial factor, I'm sorry, a binomial factor. Actually, this method of finding a common binomial factor can be very helpful when we are factoring an expression that has 4 terms. An expression with 4 terms is just a general polynomial. I know when you have 3 terms, it's called a trinomial, and 2 terms is a binomial, but there's no special term for a 4-term that I know for a 4-termed expression. But suppose I gave you something that looks like this. 3xy squared minus 6y squared plus 4x minus 8. We're going to be doing something called factoring by grouping. That's what we're aiming for, factoring by grouping. Now, what happens here? I do what I've always done when I see an expression and they say factor it. I look at the numbers, the coefficients, 3, 6, 4, and 8. Unfortunately, the only number that goes into all of those is 1. We're really not interested in 1 as a common factor because 1 is a common factor of everything. We usually don't put the 1 there. Then we look at the x's. Well, this has an x, but this one doesn't, so there can't be a common factor of x. And if I look at the y's, this has a y and this has a y, but these don't. So if I look at all 4 terms together, there is no single common monomial factor. So what I sometimes do is I sort of make a break between the first 2 terms and the second 2 terms and try to find a common factor between the first 2 terms and another common factor between the second 2 terms. In other words, I'm breaking this up into 2 groups. There are 4 terms. I'm going to take a group with 2 terms here and 2 terms here. Okay, so if I look at this first group, the 3x squared, xy squared, and the 6 minus the 6y squared, first of all, in terms of the coefficients, this has a 3 and this has a 6, so I can put a 3 there. And on top of that, this has an x, but this has no x, so there's no common factor of x. But this has a y squared and this has a y squared. So therefore, y squared is also a common factor of these first 3 terms. Well, if I take out of this first 2 terms, I'm sorry, the first 2 terms, we're just doing 2 at a time. So if I divide the first term by the 3y squared, the 3 into the 3 cancels out. There's nothing into the x, so I put down the x. The y squared into the y squared cancels out. So all I'm left with is a plain x for the first term. Then I go to the second term. The 3 into the -6 gives me -2. The y squared into the y squared cancels out. All right. That takes care of my first two terms. Now I go to my second two terms, my, my second group. First, I look again at the coefficients. This is a 4 and this is an 8. So obviously 4 is a common factor. And that's it, because this has an x, but this doesn't. So I take out the 4. 4 into 4x gives me x. And 4 into -8 gives me -2. So then I end up, after I grouped it 2 and 2, that I have a common binomial factor. That doesn't always happen, but if it does happen, then I can do exactly what I did before and take my x minus 2, my common binomial factor, and put it in the front. And my second parentheses becomes 3y squared plus 4. This is what's called factoring by grouping.
The answer is the last one at the bottom.
This is our final answer,
Okay.
where we have one binomial times another. But notice how it took 2 steps. We first had to find the common binomial factor. We first had to group it, and once we found a common binomial factor, we were able to take it out. Okay, Melissa.
Good morning. Oh my gosh. Shirley is the only person that helped me to get in. Like, I could not get in for anything. Good morning, class.
Do you know what was the problem?
What was it?
Good morning.
I have no clue what the problem is because I have no clue, Professor, I swear.
Okay, well, I'm glad you're here. Can I make you, are you ready to be a host?
Yeah, you can make me host.
Okay, so I'm gonna change you to the host now. Let me find you. And I think everybody's pretty much on. Okay, here you are. Okay, so now you're the host. Okay,
Okay.
thank you. All right, shall we try another exam? Can I give you one to try on your own? Something of this nature. Everybody ready to try something like this?
Yes.
Okay. So let's say I gave you this example. I'll leave that on the board so you can compare it. 4x to the third plus 12x squared. No, that's, oh wait, I'm sorry. I'm gonna change this. Let me do a different one. Because this one I'm gonna have to do with you. X to the third minus 3x squared plus 4x minus 12. See if you can use this method of grouping to get that one. Does everybody see that question clearly? Okay. Anybody want more time? Okay, so then let's look at this problem and see if we can do this. Again, we do what we did before. I look at, first of all, there's no number in front of the x cubed, which means it's 1. So there's no common factor of a number. And I look at the letters. This has an x, this has an x, this has an x, but this has no x. So x can't be a common factor of the whole expression. So again, we're going to, when we have that situation, we break it down the middle and see if we can find a common factor in the first two examples and a different common factor in the second two terms. So between the x cubed and the x squared, they both have x's and the lower exponent is the 2. So x squared is my common factor. And when I divide the x cubed by the x squared, that leaves me plain x. 3 minus 2 has an exponent of 1. And when I divide the -3, well, this is -3 divided by 1. That's giving me -3. And the x squareds cancel out. So my first two terms factor into x squared and x minus 3. My second group of terms, I have a 4 and a 12. So the common factor there is going to be 4. But this one has an x, but this one doesn't, so there's no x term. When I divide the 4x by the 4, it gives me x. And when I divide the -12 by the 4, it gives me the -3. So that I end up with a binomial common factor of x minus 3. So I put the x minus 3 in the front. And in my second parentheses, I put x squared plus 4. And this is my final answer because I can't go any further on this. It can't be factored any further. We're going to remind, at the end of the term, I'm going to remind you of another type of factoring we had learned on Friday, but I'm concentrating on now examples that have 4 terms. How many people were able to do this problem? Is it Ashley?
Professor, I was able to do it, but I kept the 3x squared in the front instead of the x squared.
You, instead of the, wait, over here, what did you?
Yeah, I
what
put
did-
a 3 in front of that.
Well, notice the 3 is not a common factor because the x cubed doesn't have any 3 with it.
Okay.
You can only use 3 as a common factor if both terms have a 3 with it. Or one is a 3 and one is a 9, something like that.
Okay.
You see why 3 is not a good, would not have been a good choice.
Yeah,
This
that's
is
the
really understood. So therefore, between 1 and 3, the common factor has to be 1. You want to put the 1 there, you can. It's not necessarily. When we just put a plain x squared, it really means that it's a 1x squared.
Okay. Okay.
Is that clear to everybody?
Yeah.
Okay. Knowing how to do this factoring by grouping is extremely important. for-
Professor, could you go over
Yes.
it one more time, please?
I'm sorry?
Could you
Stacy?
go over the problem one more time, please?
Sure. I'm going to rewrite it and do it over here, okay?
All right, thank you.
Okay, so we started out with x to the 3rd minus 3x squared plus 4x minus 12. And we decided we're going to do this by grouping, so we're separating it. Now I just look at this first group. Remember, where there's no number in front of a variable, that's really understood to be a 1. So between, in the first group, this has an exponent, a coefficient of 1, and this has a coefficient of 3. What goes into both 1 and 3?
1.
It's only 1. And in terms of the letters, there's x's in both terms. So I look for the one with the lower exponent, which is the 2. So it's 1x squared. That's my common factor of my first terms. So I have to divide that out. 1 divided into 1 cancels. X squared into x cubed. I subtract the exponents, 3 minus 2 gives me an exponent of 1, so it's x to the 1, which we just write as x. Then I do 1 into negative 3. Negative 3 divided by 1 is negative 3. But the x squares, this is 2 minus 2. When the exponent is 0, it means it's canceled out. We don't put it down. There's no x left. We don't write x when we write x, it means x with an exponent of 1. X to the 0 means the x's are, there's no x's in that term. Now I go to the second one. That's plus 4. Plus 4x minus 12. And I look for a common factor of those. So again, I look at the numbers first. This is a positive 4 and this is a negative 12. So 4 goes into both of them. So I put down the 4. Then I look for an x, but this term has an x, but this one doesn't have any x in it. So x is not a common factor. So the only common factor between these two is the 4. So now I divide. The 4 gets canceled out by the 4, and it just leaves me the x. The negative 12 divided by the 4 gives me negative 3. So again, my second binomial again becomes an x minus 3. In other words, x minus 3 is a common binomial factor. So I can put it in the front, x minus 3. And then what goes on the second parentheses is the 1x squared, which I usually don't put the 1 there. I just write it as x squared. But if you wrote it 1x squared, it would be considered completely correct. And the other thing that goes in there is the plus 4. Is that clearer now?
Yes, it is.
Okay. So I want to do one more with you and then take it to the next step. Okay. Can I erase this?
Yeah.
Okay. Suppose my question had been, four x to the third. I'm taking this off the sheet, by the way, it's number 15, plus 12x squared minus 9x minus 27. And I want to do this with you because this one has a little bit of a trick in it that I want you to be aware of. Get rid of some of this other mess here. Again, whenever I'm presented with an expression and they ask me to factor, I first look, is there something that goes into all the terms? Well, this is 4, this is 12, but 9, nothing goes into 4 and 9, so there's no common number. Also, this has an x term, this has an x, and this has an x, but the last one has no x. So if I look at the whole thing at once, there is no common factor for the whole 4 terms. So I'm going to try what I've been doing in the last couple of problems by grouping it, just taking the first 2 and find a common factor of the first 2, and then going to the second one and see if we have a common factor of the first 2 over there. Okay, so looking at this, there's a 4 and a 12. That has a common factor of 4. And an x third and an x squared. So that also has a common factor of x squared because the lower exponent is 2. Now, what are we left with in the middle? So the 4 into the 4 cancels out. The x squared dividing into the x cubed, we get 3 minus 2. My exponent is 1, means I have x to the 1, or just plain x. Then I do 4 into 12, and that gives me 3. And the x squared is canceled out because 2 minus 2 is 0, means there's no x's left. So my first group of two terms, I can factor it out into 4x squared times x plus 3. So now I have to go to my second group. And here's something we have to be aware of. Until now, in our second group, we always started out my second group with a plus sign. But in this case, the second group is starting out with a negative. Now, when it turns out that when you're looking for a common factor, if your first term is negative, then part of your common factor has to be the negative. Since the first term in this group is a negative 9, instead of just using 9 as a common factor, I'm going to include the negative as the common factor. So notice negative 9 goes into both of these terms. So I'm going to put the negative 9 on the outside. When I divide the negative 9 into the negative 9x, the negative 9 cancel out and it just leaves me x. And when I divide the negative 9 into the negative 23, the negative 27, negative 9 to negative 27 gives me positive 3. So whenever my second group, or anytime you're looking for a common factor and your leading coefficient, the thing you're starting out with, is negative, include the negative as part of the common factor. Now, if I look at it, I see I have a common binomial factor of x plus 3. And in my second parentheses, what I'm getting is 4x squared, putting the things that are just on the outside, minus 9. And now I've taken this 4-termed expression and I have factored it into 2 binomials. Does everybody see this trick over here of including the negative as part of, if I had to put a plus 9, this would have been a negative x and a negative 3. We want to make sure that our first term is always positive inside our parentheses. So when that first term is a negative, use that negative as part of its common factor. Any questions about this? Now, I want to tell you that actually I could even have gone further on this. And this is something that we're always going to have to do. When we factor, we always look at our last term expression and think, is it possible to do more? Can we factor more? Well, let's look at this. The x plus 3 is as simple as you can get. You can't break it down any further. So let's just bring that down. But the second parentheses, 4x squared minus 9, is that special case that we learned on Friday, where you can factor if the first term is a perfect square and the second term is a perfect square. It's what we call the difference of squares. We can break that down into 2 parentheses. We break the 4x squared down, we take its square root, and we get 2x and 2x. And the 9, we take its square root, we get 3 and 3. And in one parentheses, we put a plus, and one we put a minus. In other words, the difference of squares factors into what we call conjugate binomials. So always look, when you're doing your factoring, is your first, do you have two terms? Do you have a binomial? Is the first term a perfect square? Yes, 4x squared is 2x and 2x. Is your second term a perfect square? Yes, 9 is 3 and 3. And is there a minus? It's called the difference, that means subtract, of squares. This is a square and this is a square. Then you can, it's just something you have to notice. Then you can break it up into its two conjugate binomials. So the final answer, if you had just come up with this, I would have given you credit. But eventually, when we're really doing all this factoring, this is something we have to look out for. Can we, after we've done one factoring, can we go even further? So that was really a trick question. Okay, does anybody have any question about this? Okay, I'm going to give you one to try now. Okay, do you want me to leave this on the board?
Yes, hold on. Let me finish copying it.
Okay, so I'm going to give you another one on the other side. And see if you could do this one.
Okay, I'm done.
Oh, okay, I'm going to write it over here in any case. Suppose I gave you this, 4x cubed plus 5x squared minus 4x minus 20. Let's see if you can factor that. I'll give you some time to do that. Okay, I'm going to erase this now so I can write that one over here. All right, does anybody want to tell me what to do? Anybody want to walk with me through the steps? Anybody? Any volunteers?
I'll try.
That's great. That's all I want is trying. Okay.
All right.
What did you do first?
I had to break it into two things, right?
Okay.
So now let's start on the left side. I think what I did, I put x squared as my,
Right, because this is a 1, so nothing,
Yeah.
the 5 is not the common factor. So you just put an x squared, great.
it can't be x3 because of the x square on the other. Okay, so let's do that now. So now x cubed divided by x2, I put x.
Right. 3 minus 2 is 1, so that exponent is.
Yeah, so we're good there. So now 5x squared divided by x squared is just going to be 5.
Correct.
Hold on, my dog is barking. Just give me 1 second. Slayer. Okay. So now -4 is going to be the common factor
Right.
there because they're both negative.
With a negative, so she has to use the negative as
Yeah.
part of the common factor, and 4 goes into both of them.
Yeah,
so
it's perfect. But there's no x, so okay. So now let's open the parentheses. You did that. That turns into the 4x. The -4x just turns into an x. And now -20 divided by -4 is is 5, right?
It's a plus 5.
Yeah, it's a +5. Close, and then that's
Positive, right?
that's as far as I got. I know there's a third term, right? Or no?
Okay. Now what do we see?
That in the parentheses is the same exact thing.
Right, so what can I do with that? I can put that parentheses first, the x plus 5. And now in the second parentheses, I just put what's on the outside.
Oh, so x squared and -4.
And am I completely done now?
I don't think so.
Why not?
Because you have a
Could I do anything more with the x plus 5?
No,
No.
but you can do something with the x
So
squared.
what about the x squared minus 4?
I don't know.
Can we
yes,
do
Okay,
something
so-
with the x squared minus 4?
yes.
That we talked about this on Friday. This is a perfect square because it's x times x. And this is a perfect square because 4 is 2 times 2. And the sign in between them, this is very important. The sign in between them is a minus.
Mhm.
Whenever that happens, you can go further on that. You take the square root of the first term, so you get x and x. And then you take the square root of the second term, which gives you 2 and 2.
And then negative and positive.
Right. And it doesn't matter if you put the negative here and the positive here, and the positive here and the negative here. And of course, don't forget the x plus 5. Well, most of them you really stop over here. It's only if this expression can be broken down further, which in this case it could. Are we okay with this now? Everybody okay? So let's
I'm a little confused. I understand the whole entire thing, but I'm a little confused on how you got the x2 on the top.
this, okay. I'm looking at the x to the third and the 5x squared. So remember, this is understood to be a 1. So between 1 and 5, the only common factor, the only thing that goes into both a 1 and a 5 is a 1. So I don't bother putting it down. It's sort of boring. So then I look at the letters.
Okay.
Both have x.
How much work left? Huh? Listen.
I'm doing more work.
All right.
I'm gonna have to, oh, okay, she muted herself, okay. So when I'm looking for the common factor of letters, I make sure they both have the same letter, and then I pick the one with the lower exponent. This has an exponent of 3. This has an exponent of 2. The lower exponent is 2, so x2 is the common factor.
Okay.
Now, did you understand how I got the x was 5 once I had that?
Yeah.
Okay, so the rest you understood?
Yeah.
Okay, great. Any other questions? All right, why am I spending so much time factoring 4 terms? Because if we looked at our examples, most of our examples really only are either binomials or trinomials. Usually don't deal with things that have 4 terms. It's going to be because of the method that I'm going to teach you of factoring of trinomials. I'm going to just start with it. This is where we're going to continue next time. Right now, I'm just doing preparation for the most important type of factoring that you have to know, and that is trinomial factoring. Now, in order to talk about trinomial factoring, I want to first talk about what is factoring. Factoring is taking something that's been multiplied and going back to its original state. What was it before it was multiplied? Sort of unmultiplied. Factor means find the 2 multipliers that you have the answer. So let's remember how we multiply. Let's take a simple multiplication. Suppose I had x plus 5 times x plus 3. Now, remember, these are 2 binomials, and one of the methods that we use in multiplying binomials is what we call the FOIL method. We have 2 terms and 2 terms. We're multiplying 4 things. F, our first, x times x, which is x squared. Outer, which is the x times the 3, or plus 3x. The I, which stands for the inner, which is the 2 close to each other, the 5 and the x, which is plus 5x. And the L, which stands for the last, 5 times 3, which is 15. Actually, whenever you're multiplying 2 binomials, you're really getting 4 terms because you're multiplying 2 things by 2 things. But usually what happens when you do that is there are like terms. And you're able, usually it's the inner and the outer, you're able to combine them so that in simplest form, this becomes x squared plus 8x plus 15. That's multiplication. So now I want to talk to you. What should you do? I'm going to leave this on here, but what should we do if my original example that I gave you is the trinomial x squared plus 8x plus 15, and I said factor it. Factor it means break it up into its original things that you were multiplying. And really, we know that we originally multiplied 2 binomials. Usually, when I have a trinomial, it usually means, it doesn't always, not always possible to factor, but if it's possible to factor, it usually is factored into 2 binomials. Now, how am I going to find those 2 binomials? The whole problem here is that if I had the example as x squared plus 3x plus 5x plus 15, I would have had 4 terms, and I could have used my grouping method. But when it's written as 3 terms, I can't use grouping. In order to use grouping, I really need to have 4 terms. And the reason I don't have 4 terms is because the 2 middle terms have combined to 1 term. So if I want to go back to the grouping, I want to take this middle term and break it back up into the 2 terms it originally was. Well, how did I get the 8x? Well, there's a number of ways we could have gotten 8x. We could have done 2x and 6x. We could have done 1x and 7x. We could have done 4x and 4x. There's so many different ways that this 8x, how do I know that it should have been originally 3x and 5x? What tells me, how can I take this middle term and break it up in the right way that it'll be set up so that I can use the grouping method? So I'm going to show you how to go and figure out what is the best way of breaking up this middle term into 2 terms so that I can use this.
You don't just bring it back to what it was before?
Well, but if I started out, how am I going to know? Yeah, I have to break it up into this, but if this is the problem that I'm presented, I have a secret. I know this is what it came from. But what if I just gave you this? How would you know what it was before? So I'm going to tell you how to figure out what it was before. Okay? This method is sometimes called the AC method, if any of you have used it. Here's what you do. In a trinomial, there are usually 3 terms. The number in front of the first term, and we have it arranged in what we call descending order. The x squared first, then the x, then the number. That's descending order. The number that's in front of the x squared is called the a. The number in front of the x is called the b. And the number that stands alone is called the c. What we do is we multiply the a times the c. Now, in this case, when your leading coefficient happens to be 1, there's no number in front of it, the AC in this case is just the 15. Okay. What we're looking for then, and here's what we first look at the sign. It happens to be a plus sign. And I know I'm looking for 2 numbers that are going to multiply to 15. Remember, the 15 comes from multiplying the 5 and the 3. The result of the 15 is by multiplying 2 numbers. So first I look at the sign. The sign of 15, there's no sign there, so it means it's positive. So in order to get there, I either would have had 2 positives or I would have had 2 negatives. It couldn't be one being positive and one being negative, because if I multiply a negative and a positive, I'm going to get a negative. So when my final term is positive, it means either both of my numbers that I'm looking for, the numbers that I'm trying to break this up into, either both have to be positive or they both have to be negative. And I can tell what it should be by looking at the middle term. The middle term is positive. It must mean that the 2 numbers must have originally been positive. If this would have been a negative 8x, then I would have meant that my 2 numbers would have had to have been negative. So number 1, we look at the last term, we take care of the signs. The sign of the a times c is positive, means either we're going to have 2 positive numbers or 2 negative numbers. And we look at the middle, and whatever that middle is, they're both going to be that sign. Then what we do is we look for two numbers that multiply to this number. So what numbers multiply to 15? Well, they're a number. It could be 1 times 15. It can't be 2 times anything because then it would be fractions. It could be 3 times 5. It could be, and that's it, because 5 times 3 is the same, and 15 times 1 is the same. Now, which would be the better choice? Well, we're looking, since this is a plus, this was a positive 15, so we're trying to add numbers. We're looking for two numbers that when we add them, give me this middle term. Now, 15 and 1 add up to 16. That's not it. So it must be that we must break this up, but the 3 and the 5 give us 8. So instead of writing this as plus 8x, I break this up into these are both pluses, remember? The plus 3x and the plus 5x. And we leave the x squared, we just bring it down, and the 15, we just bring it down. In other words, what we're going to be doing, I'm just going to finish this problem for you, but we're going to really be doing this next time, is we use tricks, and I'm going to give you my whole list of tricks. There are about 4 or 5 tricks to find the right way of breaking up that middle term. In this case, when the a times c is a positive number, both the numbers have to multiply to this number, but add to this number. And usually it's not hard to figure out. Once you've broken it up, now you can use your method of grouping. In your first group between x squared and 3x, the common factor is x. X into x squared gives me x. X into 3x gives me 3. In my second group, my common factor is 5. 5 into 5x is x. 5 into 15 is 3. Just like we did before, now that we have 4 terms, we can use our grouping method. And we see that x plus 3 is our common binomial factor. So our x plus 3 goes first. And in our second parentheses, we put the x plus 5. And it wouldn't have made a difference if I had written this as plus 5x and plus 3x. The end result would have been the same. In other words, and this is where we're going to continue on Thursday. We're going to continue with factoring trinomials and trying to figure out the best way to take a trinomial and put it back into a 4-termed expression so that we can use grouping. This
The x squared plus 8x plus 15 is the answer? Sorry. The x squared plus 8x plus 15 is the answer?
No, the answer is, remember, that's now we started off with the x squared plus 8x plus 15, and we factored it back to the x plus 3 and the x plus 5. In other words, I took my answers and I showed you how to get back to the original.
Okay.
Okay, so this is just an introduction. I'm going to stop right here. Don't worry about this trinomial factoring. I just wanted to give you a little taste of why we spend so much time, or why we spend effort in doing factoring by grouping, because really factoring by grouping is used in trinomial. It's not the only way to do trinomial factoring, but it happens to be a method that is, once you've mastered it, always works. Does anybody have any questions? Again, don't forget, if you did not do quiz 2 yet, make sure to get it done in the next couple of days. It's still open. if you didn't do quiz 1 and you want me to reopen it, you can send me an email. If you did quiz 2 and you're not happy with your result and you'd like to do it again, send me an email. I will reset it for you. I will reset it even a third or fourth time until you figure it out, because I know part of it is just using the system. Also, starting, I guess I'm going to start it on Thursday after class. I will give you a test. It will be available starting after class on Thursday on Blackboard on chapters 1, 2, and 3. It's a 15-question multiple choice test, similar to what your midterm is going to be like. It's going to give you practice for the midterm, aside from the fact it's a test and you have to take it. But it's in order to prepare you not only to give you a test, but also to prepare you. I'm giving you that type of test so you'll be prepared for the midterm. Does anybody want to ask me any question before I leave? Melissa's going to take over now. And I'm going to leave her in your good hands. Any questions? Okay. All right. Have a good day. I'll see you on Thursday. And I am.
Okay, Professor.
Bye-bye.
Bye.